Hello, everyone. My name is Nathan, otherwise known as Old Man Builds. We have Sean Calderon here. Did I say that right? And
Calderon.
Calderon. That's right. I always say it wrong.
No
And we got the
worries.
benefactor here. Ben, how you doing?
What's going on, everybody?
We're going to have some fun today, guys. So Sean's going to give a presentation here in just a few minutes, but we have the return of the Zappy device.
Oh, I'm totally stoked for this, Nathan. This is
Okay.
Oh my god.
So I'm going to plug this in and zap my face a couple times, and then we're going to convert it to a mini Tesla coil. So this is just going to be some fun times, guys. So like I said, Sean's going to give an awesome presentation on some Tesla coil stuff, and then Old Man Builds is going to zap himself.
And this is Sean's his method of making that like small personalized portable Tesla coil, right? So I've been really excited for a breakdown of this and to see you build it live. This is gonna be really exciting.
Thank you.
Yeah,
I appreciate that.
It's pretty easy, right, Sean?
Yep. Just take a screw out, and you're going to need wire cutters to kind of chew on it a little bit to remove some plastic, and a little black tape, electrical tape, to wind it so it fits snug back in. And then you'll put the needle on, and you'll have a handheld Tesla coil. Oh, you're awesome, dude.
Nice.
You totally got it, man.
I'm ready to go, man. I'm prepared.
Hey, Mr.
Thank
Lanius,
you.
how you doing?
Go on, Jarvis.
Jar.
All right, Sean, are you about ready to go? You want to put up your presentation real quick and make sure it goes up?
Yes, I'm having a little technical difficulty here. Can you give me about 1 minute?
Yeah, go for it.
Sorry about that.
So we can give you guys a quick update with the Thunderstorm generator if you'd like, while he's getting that ready.
Yeah, you say Thunderstorm generator?
Yeah, so Malcolm Bendel is pairing up with a company, and they've already started producing do-it-yourself kits for the Thunderstorm generator available now. They're about
Really?
$7,000 for a kit, but you can go on and get one now. I'm not sure what the website is. Jordan from Alchemical Science didn't release it publicly because he wants them to be able to, maintain their or get a good decent stock available so they're not like, out of them when people rush to the website. But yeah, apparently they're available on the website now. I'm not sure which website.
Very cool.
Yeah.
That's crazy, man. All this stuff about plasmoids. You know Bob Greener's going to have one.
Yeah. It's going to be awesome. And then Malcolm was also talking about plasmoid infusion. And he said when he infused himself with plasmoids, he did it with negative electricity, like negative plasmoids, 250,000 volts per pulse.
Wow. It's incredible.
Yeah.
Incredible.
Yeah, it's insane. He
You
said
got to have some real plasmoids to do that, huh?
Yeah, but you can imagine, like, you probably accidentally embed yourself if you accidentally electrocute yourself with negative electricity to some extent, right?
Yeah, well, that's why you use the negative, not the positive.
Mm-hmm. It's interesting to think about.
All right. Do you see a blurry picture on the screen?
Absolutely.
So forgive this poor image. But the way the software works, you need to start with a photo, not a video. Otherwise, it jams up the works. Yeah, Nathan knows that.
Yep.
So I just had to grab a quick photo, and unfortunately, is one of the worst photos I have. So,
okay.
So Nathan, I'm ready when you are.
Okay. Real quick, I just want to, Ben, can you please clarify what it means, Alpha Tech? If you can answer that. Oh, Sean, your presentation just went away.
Alpha Tech. I'm not really sure what Alpha Tech, what you're referring to, Jalapeno, means for Alpha Tech. Yeah, I'm not sure. Maybe that's the company. Maybe he's referring to the company that's actually doing the do-it-yourself kits. Because I don't know what the name of the company is. So.
Okay. We'll worry about that later, Sean. I'm going to remove us out. It's all yours.
Oh, yeah. Take it away.
All right. Thank you, guys. Thank you so much. Just now figuring out where my brain is. 1 second here. Awesome. Okay, so can everybody see a blurry screen? Nathan?
Yeah, we see it.
Awesome. Okay. Well, hey guys, it's really great to be back. I missed you last Wednesday. I couldn't help it. Some health issues. And so I haven't got a lot accomplished, but I'm just going to kind of share with you what I'm tinkering with in the lab and what I've got going on. So right now what you're seeing is the white ring here inside the copper pipe bowl. It was a mistaken print job, so it ended up a disaster. But yet you'll notice here that I'm using it for another purpose, and that is to center this new coil that I just wound. So this is one of my sphere coils I call Amber. Amber is the name. It's very, very pretty. Nathan, for some reason, the screen is really small. Does it look small on your side?
Oh, it's small, all right. It might just be the video.
Let me check here real quick.
It's full screen for what it is.
Try holding control and scrolling up on your mouse with the mouse wheel.
Yeah, that works with photos, but I don't know if with videos.
Yeah, that's worth a try.
I think I didn't share this correctly, to be honest. So I'm gonna unshare. Sorry about that.
Oh, hold on. No, it's there now.
There we
It's
go.
full screen now.
Yeah.
Yeah.
Okay.
Just glitchy.
Oh, that's so weird. Oh my goodness. Okay. Awesome. Here we go. All right. So I just finished winding a translucent sphere similar to the Death Star, but it's sort of in that clear, almost transparent. And when I coated it with epoxy, it came out looking really nice. It's interesting how when you look at this in person, this thing looks pure gold. In the camera, for some reason, it has all these gray, smudgy areas. And it's not in real life. It actually looks all smooth. So I'm not sure why, but it's one of the more prettier coils that I put together. And I'm going to run some electricity through it. This will be sort of my last sphere Tesla coil for a little bit. I'm going to be moving to different geometries, and I'm working on electrets and a lot of good projects. So I'm in love with this little coil. It's so pretty. So I thought I'd share a few videos of it. Like I mentioned, it's 12,000 plus turns of wire, and it's 33 gauge wire. For the secondary, I had found some, it looks like almost like a bike chain wire at the thrift store for $1. So I just wound it around this form that I had printed, and yeah, it worked. It seemed to work really well. Now I'm going to show you how the first connection setup is for the sphere. Here it's just connected straight to ground, and so connected straight to ground has this look, this appearance to it, and this looks similar to the other spheres that I've designed. So it's still mesmerizing, still pretty. It's but not too different. So this is connected to the earth ground, especially in my house is built 1902. There's these large copper rods. They go deep into the ground, and it's connected to the house. When this house was built, lightning storms could burn your house down. So they were very particular about grounding their house. And so that's the grounding I'm using there. Now, in this setup, I'm going to use these copper spheres as ground and see what happens. Because without a good ground, none of the Tesla coils that I use with the ZBS circuit will not put out any arcs or sparks. So the ground needs to be good, at least good, for you to get good sparks. But I'm going to try these spheres, and here's this picture's out of order here. I'm showing you. Okay, so I'm going to show you how I connected it. There we go, right to the copper spheres. I can show you. These are solid copper, 2 inches in diameter, and they weigh 2.7 pounds each. It's real strange when you hold them in your hands because they weigh so much, but it's fascinating. So copper has the most free electrons, and the only thing that beats copper is silver. Now, this is what it looks like using the copper spheres. Now, this surprised me, to be honest. I didn't really think a few copper marbles can act as such a superb ground. And I think this is going to be really interesting because now I can build it a little bit more self-contained, and I don't need to rely on using other people's grounds if I want to show them it at their houses. And so, yeah, those copper spheres did a pretty awesome job. I look forward to the questions regarding this, but I thought I'd share this. I'm really digging into the core here, and it's because, and look at that, it doesn't even touch the camera. These sphere Tesla coils are just so balanced. It's so amazing. It's so interesting because 99% of Tesla coils, you'd never put your camera a couple inches away from it. No way. It's be bad news. So that's really unique to these designs. Now, here was my intention to do the slow motion on my iPhone. And it's weird because of the way the slow motion works. It's slow in using its slow motion. If that makes sense. The one thing though I like about this video is, if you remember in the previous, just the last video of plasma discharges, it looked like sort of almost a full bouquet, if you will, of plasma. Here, though, you're only seeing one single strand, maybe 2 single strands, but it's more really one strand at a time. So this slow-mo gives me insight into this is what's really happening, but it's happening so fast that it looks like it's more fuller when we watch it in real time. And so that interested me here, is that, okay, this is what it's really doing, but it's doing it so fast that it looks like a bouquet of plasma versus these little lightning strands. And this is like take 25. Slow-mo of this is so painfully arduous, but I'm glad to share it with you guys. All right, this last one, I'm going to connect it to the copper spheres as well as to the earth ground. And I'm also going to put this little muffler on it. This is something that surprised me. This little sphere is really loud. It's so noisy. You need hearing protection almost for it. But if I put this little coil here of iron, soft iron coil, it immediately changes the sound to a hush. So this was interesting to me. It's almost acting like a muffler. So I thought I'd share that. Pretty cool. And this is with both grounds. And I immediately noticed the intensity. It's greater. And also too, when the lightning strikes, if you'll call them, the plasma discharge. Okay, so I just blew my circuit breaker, my 20 amp circuit breaker. That's how powerful this thing is. And it's 50 volts. 50 volts going inside, 20 amps. Over 20 amps when it goes dark. But look at that. I mean, 2 grounds. The copper spheres, my house ground, and the muffler. And so it's quiet, and it's in your face powerful. And so I thought this was a success here for Amber, my new coil Amber. Let the circuit breaker here pop as the finale. All right. So if you'll notice this screenshot I took, it actually goes off about 3 inches off the screen. If you look at both the spheres and the house ground, that it sort of shoots off the screen and off the screen. So my estimate is that these sparks with both grounds are hitting the 12-inch mark. And I've done some sizing analysis to get that. I just used the sphere, which is 4 inches in diameter, and start extrapolating. So this little guy can put out about 1,000,000 volts if my math is right. And you're seeing it right here. So yeah, muffler helped, the double ground helped, and it's a nice way to soup up your Tesla coil. I actually measured the capacitance of that little coil of iron wire, and it's 740 picofarads. So it was like adding a capacitor here on the tip. So pretty cool. Now, this is when I look at the plasma, this is what I see. I see people, I see faces, I see this guy pulling in some rope. And I just thought I'd get the Sharpie and just draw one out. But this is kind of how my mind works. So it's a bit mesmerizing, but it also sort of spurs art. And I know it's sort of a sloppy art, but to me it's fun. So I thought it would be fun to share with you guys. All right, so I took my black coil, I put it on its side, and I just wrapped around like a flat copper piping, and that's it. I use the ZVS is the same, the setup, the capacitor is the same. Everything is what I do is normal. The only thing I do is turning on its side and have the top end that goes to one side and then the bottom end that goes to ground on the other side. And so that's just a Tesla coil on the side, easy stuff. I'm not getting the greatest resonant frequency from the copper pipe, but I just threw it together for demonstration. These are those copper spheres again. I tried to use the copper spheres because copper has a lot of free electrons. I thought it would be a lot more powerful in its display, but this was just kind of a dud. But it's something that you can replicate real easy, and I just kind of wanted to show more of the concept. But yeah, that's about as big as the arcs I could get off this thing. Nothing too exciting. So yeah, this is a Starbucks cup, plastic Starbucks cup, the black coil, and some PVC pipe, and that's it. You got your ZVS coil. You're ready to go. I think this is another setup or another experiment. I think I'm doing more of a close-up here so you can really see it. And so don't be afraid to experiment. If you have a Tesla coil secondary, just turn it on its side. And instead of the primary coil, the coil 1, just try to stick it in the middle and you're golden. Kind of showing here how it's set up. So at thrift stores, I picked these up. They're acrylic, and I picked them up for about $1.99. Here's like the venti cup, and they're all acrylic or some kind of clear plastic, and the same clear plastic that I'm using here. So for a couple bucks, and I'll tell you what, if you try to find acrylic tubing on Amazon, you're going to pay 20, 40, 60 bucks. So yeah, I'm not paying that. So I try to get all my acrylic materials scavenged from thrift stores. So here's my famous little piece of wire in the probe of the oscope. And here I'm measuring the signal or the waveform of that bipolar Tesla coil. And it's distinct because it's just ugly. It's got a lot of, it's not uniform, so it's not resonating very well. It's not oscillating very well. So I thought I'd share the difference there. All right, so the next coil I'm working on is the conical coil or the cone coil. Now, if you've ever seen a picture of an old black and white picture of Tesla's conical coil, you'll notice that it's the same dimensions roughly. Now, of course, I'm working off a photo, but if you look at mine and if you look at his, it looks like I've been able to get the same dimensions. So this guy has about 10,000 turns of 33 gauge wire, magnet wire, And so I'm going to start processing that, getting it ready to be my next coil. There's something about that I read where Tesla writes he was able to get into the hundreds of millions of volts out of the cone. And so it's interesting to me that I sort of let this fall to the side. For me, the least two interesting experiments I had was I thought my head would be a cone and a sphere. And it's interesting that the sphere and the cone have garnered the most interest. And had I known that, I think I would have focused on them better. So this is what it looks like when you pull out of the mode. It looks really ugly, and there's some bad spots. So what I do is I'll take a wire brush and I'll clean out these spots. And then what I'll do is I'm gonna use the cone upside down and right side up. So I had this coil pre-wound, and so I thought I'd just test it. And here's this venti cup. And so I'm gonna cut this venti cup so it fits. And you'll know my signature hot glue on the top to protect the little wire so it doesn't get broken off. Now this is really interesting right here. This is, see here, if I can, here we go. Let me pause it here. So this inner ring here is made out of ferrite. If you ever take apart a CRT, a large tube television, you'll find that they'll have these ferrite rings, and these ferrite rings are used to magnify the waveform that is used to move the beam that hits the screen of the TV that illuminates and gives the picture. And I thought, well, how cool would it be to put this ferrite ring inside my concave primary coil 1. So I've had this problem before. There we go. So I thought that I would put it inside my concave 1/4 inch piping. I think this is actually 1/8 inch piping. And what happened was initially is I measured the inductance and it doubled. So it was 7 microhenries for just the copper alone. And then it was about 14.5 microhenries when I added the ferrite. And so I thought this is a super cool setup, and I was anxious to test it. But first I'm going to do some preparation on the venti latte cup. I'm going to cut it so then it is ready to hold the conical coil for my upside down setup. I want to start with the upside down setup because it seems easier. I think the other way is going to be harder because all I have to do now is wrap some copper piping on the Starbucks cup, and then it'll be the primary coil, and then I'll see if I can get some sparks from the top. And also it seems like it should be this way, but I'll probably be wrong. But when you start getting the resonant frequency to rock back and forth, it just, my gut tells me that if it starts small here, it'll get bigger and bigger and bigger until it's amplified. Kind of like if you use a, I forget what they call it now, where they hold a loudspeaker in their hand and they'll yell into it. It kind of gives me that idea if this was hollowed out and you would yell in the pointy part, it would amplify your voice. I'm wondering if it has that same effect. And so this is why I'm setting it up this way. Here again, I'm kind of showing off how that ferrite coil is pretty awesome. I also had to make a lot of bends in this copper wire in order to get to sit decently enough, and I'm not pulling my hair out. And then there we go. So the cone's going to go get seated there. And yeah, that was my first setup. Oh, this is my new toy. I call it R2D2. This is one of the best things I have in my lab. This thing extracts all fumes in wherever you point it. So there are many times where I want to use a heat gun. And anybody who's worked in a lab, especially if you're a man, something has to be burning. Something has to be smoking. And where I live up here in Chicagoland in the frozen north, I can't go outside and do this sort of hot glue stuff. So this little RD2 guy takes away all the fumes, and now I can start melting and not worry about the plastic fumes or the soldering fumes. This has really upped my productivity now, and I don't have to do workarounds. So you're looking at here at the conical coil. I lost the tip. That hair thin wire broke, and I'm pulling my hair out trying to get it. But it was, I just wanted to share with you that RTD2 was up for the job. So I did find it with the heat gun. And so now I have the top wire. But here's some pictures of it. Looks pretty decent. So this is where I started to clean it up. I added a layer by hand with a frosting knife, and I got to the what is it? The epoxy to thicken up, and then I put it on it, and it improved the appearance. Here I am securing the wire because I don't want it to snap again. Here we go. So this was my final, and you can just see that it looks amazing. And you can just see tens of thousands, tens of hundreds, 12,000 roughly turns of wire, and it's that 33 gauge. I've got enough epoxy on here, and I've got enough of the air bubbles out of it that should be good to go. There's R2D2. Oh yeah, it's nice too because it has a brushless fan motor, so it's not that loud. It'll also hold 2 tentacles and not just one. So I capped the other side because I didn't need it. But if I have something smoking on one side of the lab and I have smoking on my work table, I get to use these arms, and man, it makes a difference. It is makes a difference. And they're not too, they don't break the bank. Get them on Amazon. All right, we're going to talk electrets now. Actually, no, sorry. We're going to talk about, so if you guys remember, Nathan was using a fog device, and he was using it in his garage as he was running his gravel flyer. He has the high voltage, the Tesla coil, he has the ultrasound, he has all these instruments, these mechanisms, and yet it didn't really have an effect on the fog, the smoke machine fog. So I thought, man, it's a bummer. I wish it would work. But there's something called a cloud chamber that I discovered. And so what I'm doing here is I'm building this cloud chamber. Now, this picture's a little out, but I'm putting 12 volts into and 9 amps into these cold pads. I don't know if it's in this video. No, it's not in this video. This out of board, or sorry about that. So I'm building this cloud chamber, and I have all these aluminum heat sinks from broken down stereos that I buy at the thrift store. So I have every size heat sink. So here I pull this one out. I'm going to put a big fan on it. And the reason for that is this white square looking thing with wires, a black and a white wire coming out of it, that's a Peltier device. And what it does is when you power this thing up with 12 volts and a good amount of amps, the top side will freeze. It'll get to below 0 freezing temperature. The bottom side is hotter than blazes. So it's not for free. You get super cold on this side, but you get super hot on the other side. If you don't dissipate the hot on the other side, this thing will fail. And so what I'm doing here is I'm hooking up this fancy heat sink on a fan with a heat sink so it can get a lot of air and cool the bottom side of this Peltier device. So I don't have to worry about it. And now I can focus on getting it freezing cold on top. And you can buy a pack of these little Peltier devices. I think they're like 5 for $10. They're super cheap. Now in my head, I was thinking one Peltier device was going to be enough. I'm going to find out later that it wasn't. And so here I put on the conductive grease. This is basically heat sink grease. It's an all-purpose grease. If you're going to put say a MOSFET on a heat sink, you just use this grease. I despise this grease. It gets on everything. It stains everything. It never comes off. And it's funny because no matter where I go, I'll find it on me. So I'm very careful about using this evil little can of grease here, but it's necessary. You don't really want to connect things to heat sinks without it. Now, I found this little cover from a children's toy at the thrift store, cleaned it up, and look, it fits perfect on one of my heat sinks. So the idea here is I want to freeze the bottom of this encasement, and then I'm going to add 99.9% pure alcohol. And my hope is that it's going to start clouding in there. The mist will form. And then I'm going to move it toward my electrostatic devices to see what the fields look like. And this device is going to allow me to do it. So how it's going to be set up is I'm going to be putting electrons, or just basically putting one wire at the end of my high voltage on the top of this, and then I'm going to freeze the bottom, and then of course it's going to be cold on top, hot on bottom, and then I'm going to add the alcohol, and then it's going to form clouds. And if you look up on YouTube cloud chambers, you'll see similar of what I'm trying to do here. I'm just not building one or buying one. I'm kind of trying to do it myself. So I found out that one Peltier was not enough. So here I've rigged up 4, and I'm just testing to see how cold I can get things. And here's another pack of 5. So these Peltiers are not too expensive. And there it looks sharp. You think it's ready to go, but it's not. I got a lot more work to do, but I thought I'd share the progress. Also too, if you're looking at something to measure or view your high voltage waves, or the static waves are the tricky ones, this will show them. This will show what they look like. And so you'll see me here with my infrared, and look at it. They just get darker and darker, and you can see the temperature. It was about 83, and now it's 45, and it's going down further and further. So just give you an idea of how these Peltiers work. It's pretty cool. It's pretty cool to have something that will freeze, and it's cheap, and it's only 2 wires. It's no flowing liquids or anything, nothing to worry about. And so the plan is to put a piece of black aluminum on this, so that way when you see the mist change, the black will give it a contrast. And I think I'm showing it again here. You can't see them. Then I flip on the power, and there we go. Look at that. They are dropping in temperature. Look at that. The temperature dropped in half in just a couple seconds. So fascinating stuff. I know that some of you guys are going to go, oh my goodness, where has these little freezers, portable freezers or refrigerators been all my life? I feel the same way. Many of you guys might have already heard about these, and it's no big deal, but I was surprised, and I loved it. I had a good time. Yeah, 12 volts, almost 10 amps. Yeah, they gobble up the amps. Here's the bottom side. So the top side you can see got dark. The bottom side gets light because it's hot. So I'm seeing a successful transfer of heat, what I wanted. And so I'm close to building my cloud chamber. So I want to apologize for not finishing this for this video. My health has not been too good, so I'm a bit behind. My hope is, though, my next presentation, I'll have this cloud chamber running, and hopefully I can show you how to measure some electrostatic fields with it. It'd be fun. So this next picture, this is kind of a miscellaneous. So my dad, he's like a genius artist, and he's always painting and sending me photos of his stuff. He's an impressionist. And so he just sent this. So about once a week, he'll send this to me on my cell phone, and then I'll write a poem for it. So I thought I'd share that little personal side. Here's my dad with ink. So the last was acrylics. This is with just colored inks. And he does a lot of sort of obscure, interesting, again, and they're impressionists. So you see the harsh paintbrush marks. And so this is kind of how my dad and I interact. And I thought I'd share that. All right, so building electrodes. First thing you need for an electrode, and Jarvis is the expert, so I'm not gonna, if I say something wrong, forgive me. I'm very new to this. But you need a steady electrostatic field. So what I did is I measured the voltage of each of those high voltage generators. And let me just restart this again, talk about it. So this is, I measured each one of these. So the top black cylinder is a high voltage device. There's 3 of them. And I measured its voltage at 3.4 thousand volts. And that's in DC. There's a noisy AC on it that I'll talk about later. And then the middle one was 3.25 thousand volts. And then the bottom one, 3.5 thousand volts. And how did I know that? Because you just can't measure 3,000 volts on your multimeter or your oscilloscope, or you'll fry it, and you don't want to ruin your oscilloscope or your meter. So what I do is I use a spiral of resistors, and I encase them in epoxy. You don't have to do this. What I did, all you have to do, and I'll show you a simpler way. Just buy 10 resistors and insulate them, and boom, you'll be able to measure up to 30,000 volts on your oscilloscope or on your multimeter. So I'll give you the part number for the resistors, and you can do this. So I'm just showing you how, it's like an example of how it works. I've always got my infrared on, always to get insight to see what's inside. And here's one of those high voltage packages. I'm running it, and notice that it's getting hot here in a certain spot. And this thermal imager, it's not cheap, but I've used it so much that my LCR meter and this are probably my 2 most used. But this just lets me peer right into things and see where the hot spots are as compared to how much voltage and current that I put in them. These modules have a high failure rate. Out of these 5, 2 failed. So that's a 40% failure rate, not great. So one of the things I did is I'm hooking these guys in series, and with the hope of powering it with low power that would only power one of them, just boosting up the current a little bit. And then these 3 will all be working, but without a significant load. And I think that's going to prevent them from dying, because they die super easy. So this is how my setup is coming together. I have the power on this side. It's DC, comes in. There's little high voltage transformers inside that oscillate, and then they come out the end here with a high voltage diode, which then rectifies it. It rectifies the output into DC. And then I take those DC outputs and I combine them into one. So you can see here that now I have a high voltage negative potential and a high voltage positive potential. And these are now going to generate my fields. And these are the fields that I'm going to use to alter the molecules that will align. And then, like a magnet, it'll create an electret and hold an electric charge. This is the imaging of all three of those, and they stay under 90 degrees. And I found that if they get up to 100 plus degrees, then they're toast. So this is how I do my testing, is do a little bit of imaging. Oh no, I'm so sorry. I hit the wrong. Let me just fix this real quick, guys. I'm such a goof. Sorry about that. Let's take 2 seconds here. Let's see, where was I? And I appreciate you guys' patience. You're listening. I so look forward to sharing with you guys. I just have such a good time. You guys are so wonderful to hang out with. And it just makes my day. I'm smiling for like a week after these presentations. So I'm lucky because of our fearless leader, Nathan, and having such a good crowd. Ben, I appreciate you, and Nathan, and just so much love, guys. All right, tell me when you see a picture there, Nathan. Are we good? Oh, good. I can see it on my iPad.
Yep, we're good.
Awesome. Thank you. All right. So infrared, seeing where their hot spots are. Now I'm doing some testing. And what I found is the thinner the wire, the less strain on the high voltage generator. So I'm using these single thread, and they hold, not only do they arc without causing strain, but they also create a very even, strong electric field. Now, filming these are so different than filming the high frequency, high voltage from the Tesla coils. This is high voltage DC, and as you can see, as it arcs, it actually takes control of my camera and shuts it off, shuts it on and off and on and off. And so there's a mean EMP coming from this DC. In fact, if you were to connect this to a small Tesla coil, you would have such a powerful EMP device. You could destroy someone's iPad or laptop. It would just take one of these little modules and a coil. That's all. And you would destroy people's electronics. So now here, I placed the wire in a little container of epoxy, and I have that pesky resonant ring signal that I don't want because I only want DC. But what I'm showing here is, and this is something Jarvis said, hey, you got to walk before you sprint. This is sprinting, and I had to get it out of my system. So it basically turned out just as poorly as Jarvis had warned me. That's there. All right, I'm going to get back to that electric testing, but I'm going to change gears here a little bit because I want to take a step back and say, hey, okay, what is an electrostatic field? An electrostatic field is static electricity, you can call it that. And it's basically an electric charge that's formed on an insulator. And so you'll experience this when you pull your socks out of the dryer and they're all stuck together. All the strands of cotton are all going in 100 different directions. And then you'll grab the sock, let's say, and you'll walk across and drag your feet on the carpet. And then you'll touch the doorknob and whack, you'll get a jolt, a little kick, a shock. So because static electricity sits on insulators, you kind of, when you're dealing with it, you're kind of charging things and neutralizing things in ways that you don't want to. That's why you could be testing this high DC generator that I showed you earlier, the sparks. When you go to turn on the power of the power supply, you get zapped. Why? Because you're an insulator, it was charging you, and then when you go near the metal case of the power supply, bam, it hits you. So There's 100 different ways from Tuesday to get shocked all the time when working with high voltage electrostatics. It's just number one. Number two is you need to work on a conductive plate, because static will not build on a conductive plate. And so if you start moving your electrodes, which are insulators that are charged, if you put them on this plate and this plate is grounded, then you will have now a neutral area where the focus will only be on making the electret. And this will allow you not only to focus on making the electret without any outside interference, but secondly, it allows this setup here, grounded plate, could be aluminum, anything that's conductive plate. You put your testing device on this plate, you're going to get consistent readings. And so that's the purpose. I found this out the hard way pulling my hair out. So I spent a little time on that, get that nice ground wire running to the plate. I'm kind of showing that each end of the plate is conductive. So there's only 0.5 ohms between the ground and the testing device. So showing there from ground to ground, there's 0 ohms. And so I'm checking it here, each side. Now that I'm charging one of those high voltage generators, you can see that so when this is on, like, say, a plastic mat, you won't see these sparks going down, but what these things will be doing is charging that mat. And then that mat needs to be discharged, and that mat's field is going to be affecting everything. But what you're seeing here with the plate is, no, these wires can't charge the aluminum plate, because the aluminum plate, first of all, you can't charge metal. Metal cannot hold static charge, static electricity. I'll say that generally, because there's probably an exception. And then that allows you to then do your electrostatic work without all these extra fields. Now, this is my new meter. Now, I know that you guys agree with me that there's no such thing as too many meters in your lab. And so I got this, what's called an electrostatic meter. And it's got 2 laser pointers in the front. And where there are 2 of them like that, you're too far away. When you're just formed 1 dot in the middle of the circle, that means you're the right distance. So pretty cool setup. Also, to this PLA lid that I printed, it has 200 volts of static charge. So this has an electric field. And this is cool because everything has an electric field. We are all electric fields. And I won't add magnetism in that yet, but we are all electric fields. And so, wow, this lid here, not knowing it, has 200 volts charged on it. Pretty cool. And now look at this. My meter is on the metal. The meter has its own ground, so it's connected to the metal. And then house ground is connected to this plate, and voila, now your meter doesn't drive you crazy. If you don't have this specific setup, if you start moving your meter around to places and, oh, I'm going to throw it on my bench that has a black silicone cover or a wooden desk, and hey, I'm going to try to measure this. Nope. It's going to give you conflicting readings. It's going to cause you to go crazy. You have to get that neutral area, that balanced area, and then now you can start reading fields. And so pretty cool. I did a lot of fun things with this meter, because I'm like, does glass have a positive charge? Come on, does it? It does. Oh my goodness. Notice how I'm on the aluminum plate. So these are real static fields, and it's going to get up to 120 volts. Piece of glass. Pretty fascinating that it's emanating a 120 volt field. Very cool. See how I'm using an acrylic to turn on the power, because everything gets charged? I'm not touching that power button. I have been shocked too many times. Now, I'm sorry these slides are a little out of place, But what I'm doing here is I'm measuring with my high voltage probe, my homemade one. I'm measuring the voltage. And so it's showing here 67.9 volts, but I have to times that by 50 because my probe is a 1/50th probe. I'm sorry, a 50 times probe, multiply to probe. And so this is roughly about 3,500 volts. Here I am. This really fascinated me. I thought I'd share with you guys. So I'm going to move the meter here over this charged area, and it's some sand that I cleaned. I just rinsed the mud out of it. So this is just pure sand. And it's showing a reading because the acrylic cup has voltage, because of course everything has a field. But you'll notice that sand has a little bit of charge to it. Get about what, 240, 250 volts. Shake it up. And also, by the way, I shaked it up before this, and nothing fancy about this sand. Just give it a little shake, and grab my little electrostatic meter, and look at that. It's the voltage is higher. It's now 350 volts. So incredible. We're creating fields everywhere, and if we know how to use the measuring device, and we learn a little bit about electric fields, then wow, it just opens up a whole new door to you. Versus these other, look at that, we're getting up to 780 volts. Isn't that amazing? And it's negative polarity, which is very interesting. Excuse me here. All right, so now this is a grounding wire, and now I'm going to mix the grounding wire that's connected to the house ground and the aluminum plate, and I'm just going to kind of mix it into that 750 volt sand. And I'm going to get my meter back out, and oh boy, look at that. It's down to 20 volts. So I thought this demonstration would help because there's just not a lot of good how do you use this thing videos. There's either electrical engineers that put out all kinds of math and talk in some language I don't understand, or there are people who don't know what they're doing. They have no idea what they're doing with this electrostatic meter, and they'll put it in front of things, and they have no idea what they're doing. And because this is a static electricity device, that's why it says electrostatic meter. That means it measures voltages that aren't moving, and they are on insulators. That's what that means. So if you're doing anything else other than that with this electrostatic meter, my guess is that it's not right, and you're gonna pull your hair out. And without this plate and without zeroing things out, you'll get crazy readings all day. So if this helps you guys, I hope it does. Saves you hours of angst. So this is one of my foolish measurements. I'm measuring this glass sphere, see what the field is, because look, I'm on my plastic top workbench. So this was just when I didn't know what I was doing. This is a Teflon ball. This was interesting. I took 2 globs of hot glue. One I put a thin wire in. See, I'm going to pull that thin wire out. Pumped it full of 10,000 volts. And I was going to check out, is this glue glob going to have more charge than this glue glob? And look at me, I'm taking my electrostatic meter, and I don't know what I'm doing. So this is a disaster, but I thought I'd show you. Look at that. It's not reading anything, even though in a different way it will. And as I move the meter and this test piece of acrylic across this mat, it's scraping electrons, and it's giving me readings all day that are horrifying. Make no sense. I didn't know I had so many videos of this. Okay. So what's funny is The one that I zapped, I wonder if I can change the direction here. Let's see here. No. So the one on the left here was up between 5.7 and 8,000 volts. The control, the one that I didn't zap, was 0.2 or 200 volts. So even with all my wrong usage of it, I could tell that I did charge this little glob. And that's interesting because that's a little success. And to be honest, the success for me is getting things right, understanding my environment, so then I can start building some really cool stuff. And this, I think, is doing that. Like my button pusher. It's so check this out. Would you ever put your multimeter or your oscope 1.5 inches away from these arcs? Oh, no, 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 no. I'm like 12 inches away with my camera and my camera's flickering. But this electrostatic meter is made for it. This electrostatic meter yawns at scary voltage. So now electrostatic scary voltage, not AC. AC would ruin it. This is that EMP DC. Okay, I'm in the miscellaneous for free on Facebook Market. You can pick up a rear projection TV. The thing has like a 60-inch screen. It's on really nice wheels. Free if you pick it up. So I picked up a couple of them, wheeled them into my garage, and I got these ginormous flyback transformers. The one on the right is at least 40% bigger than big flybacks that are out there from TVs and computers. And then it has this right here, which is really cool on the left. And that is a flyback amplifier. So it's not enough that you're going to put out 10,000 volts from the right, but look at these. You can now feed 3 other flybacks from this one, or you could combine these voltages and it'll get amplified, and who knows what scary voltages you'll get out of it. So free rear projection TVs. Now you're thinking, well, wait a minute. Now I have this giant TV in my garage. Just get your Sawzall out and chop it in pieces. They're on really nice wheels. So I just chopped it up with my Sawzall. It took me 20 minutes. And it was a cart. So I just wheeled it over and it fit my trash and boom. And I got a lot of other cool stuff out of the TV, but I'm focused on high voltage DC right now. Once I get the cone coil done, I'm going to be jumping in more into electrics. So I'm going to set these up as one of my DC high voltage power supplies. Okay, so I sent this to Nathan and told him how to turn this medical device into a handheld Tesla coil. So we're going to have more fun with this with Nathan later after this presentation. You guys are troopers. I'm almost done. I so appreciate the time you guys listening to me, and I look forward to your questions. And here's just another miscellaneous. I'm going to my wire bin and I find a nice wire. And what am I going to do? I'm going to make my own alligator clips. The reason why I make my own alligator clips is because when you're dealing with higher currents, these things melt, they smoke, they don't handle high currents, and they can actually change your circuit. If they're not putting it, if they're getting too hot, they're turning into resistors. So what I do is in my spare time, buy a pack of these alligator clips, go out of your wire bin and just start making them. Put on your favorite YouTube channel, watch Nathan's Old Man Builds, and you're set. So I thought I'd share that. All right, here's another trick. So I have 900 nanofarads capacitors, and you'll notice they just go down and down and down until I am, let's see here, it's 330, 301. And so as I go down, when I'm trying to determine the resonant frequency, when I hook up my coils, I just start in the middle, work my way up, work my way down, because these are close enoughs. Oh, there we go. There's 6 nanofarads right there. This was 32, and this was 32, and this was 50 nanofarads. So I have the gamut. You're not going to go higher than 1 microfarad. If you do, you're doing something wrong with your ZVS setup. Now that's for high voltage stuff. If you're doing induction heating, then yeah, you'll need more capacitance. But because I've figured it out, you just need about 10 values of capacitors, and then you just start slapping them in. And then when you slap in the right one, then you dial it in. You say, okay, it's 500 nanofarads roughly. Well, what if I add like 20 more nanofarads? Oh, that's the sweet spot. Perfect. Let's use it. So I thought I'd share this. It's a cheap tip. So now that I'm delving into electrostatics, I wanted to show how I look up on AliExpress different kinds of high voltage devices. So here, and they're all relatively inexpensive. This one here is, you can see the MOSFET with its heatsink in here. So you actually have access to the circuitry. Here, this was just unique looking to me, and it boasted a lot higher voltages. And the high voltages that they boast, I hate to say it, but most of them are liars. But again, I bought the little cigar-shaped ones I showed you earlier. I'm just looking for variety. This bottom one, I think, is going to be a hit. I also have talked to Brett Jarvis. He suggested that we use, oh my goodness, a Cockcroft-Walton capacitor multiplier. And so we might be switching to that. But the cool thing about this high voltage DC supply at the bottom here is you can dial it up and down. And that's cool. It's only 27 bucks, not going to break the bank. But to dial it up from 1,000 volts to 10,000 volts, that is crazy. Because that's hard to do. It's really hard to do unless you spend 1,500 bucks on a high voltage DC power supply. You're not going to find something affordable that you can dial in. So I'm optimistic about this one. And on AliExpress, they have some meaner ones than this. This is the lowest end one. I think they have one that goes up to 250,000 volts. I was tempted to get it, but I need to. Jarvis, I always hear his voice in my ear. Hey, let's walk before we run. Oh, also, if you don't want to buy an expensive electrostatic meter, this is a neon fence. I'm sorry, it's a electric fence tester, and it has the neon indicators. So this is $7, $7.36, and you can use it to test your fields. So I thought that would be a unique way to do it and share with you guys something that's affordable. I'll share that later. Okay, so this is way off topic, but I'm severely dyslexic, and they just came out with a dyslexic font, and they came out with it in my electronic Bible version. So I was reading my Bible as I do every day, and I was reading this dyslexic font, and oh my goodness, if you have even light dyslexia, man, look up this font. So I thought I'd share that. Way off topic. Another way off topic tip. So in Europe, they require connections in this format. So you know how we'll have the open end connectors. We'll slide them in, and then we'll tighten a screw. In Europe, they have this weird tool, and what this tool does is it crimps these little round connectors around your conductor, and it's a really nice connection. You feel really good about it. This whole setup costs about 20 bucks, AliExpress, the tool and an endless amount of these little clips. And it's just really cool to just put it in there, crimp it. And I'll crimp it a couple times to get it real nice and tight. And it's better than soldering. It's better than a lot of other ways. And voila, there you go. I'll clip that tip to clean it up. And then it goes right into any any of my connection terminals, and you're set. So I thought I'd share that good idea. I wish I knew these things when I started the hobby. That's why I'm sharing. Oh dear, excuse the mess. But I do have a half-court basketball court, a lot of other things in my garage. This is, I call it airplane hangar, and you could actually fit 2 airplanes in here. So I go to the thrift store, and if I find monitors $5 and cheaper, I buy them. And so when you see the components or the acrylic or whatever I'm working with, this is my little junk area. So yeah, please excuse the mess. Yep, it's a it's a regulation half-court basketball court. Someone asked about it in my last presentation, so I thought I'd show a little bit of it. These are these Peltiers you can buy. All right, so we're almost done, guys. Thanks for hanging in there. If you take this part number down, buy 10 of them, connect them in series, and this guy's doing it. And then what you're going to do is you're going to then wrap the resistors with Teflon tape. That's what he was doing. And then you put heat shrink over it, and you'll have a 30,000 volt maximum meter. DC, AC, doesn't matter. And I think this is super important with dealing with high voltages. And it's terrible to not know because you're afraid to blow your oscope or your multimeter. And so this has been a lifesaver. I've done all the math, so you don't have to do it. It will work with your multimeters because most of them internal resistance will match. With the oscope, the internal resistance is a little off, but you'll get close enough with the oscope, and you'll get spot on with the multimeter. Oh boy, I'm going real long, guys. Just a couple more. All right, so I'm taking Brent Jarvis's good idea to hook up a PWM, and I've hooked it up to those little high voltage generators. And what I'm doing here is I'm using the oscope to measure the PWM. So you notice the hump here, the spike here on the oscope. So that's like 5% PWM. Oh boy, I forgot the word now. 5%. It'll come to me, and you can adjust that, and it adjusts the output of the spark. Here again, duty cycle. So you can see the duty cycle here. And now it's such a dirty signal because I have no idea what I'm doing. So that's why it looks ridiculous. This is my PWM. But after fiddling around with my PWM, I found out if I hook a motor to it, because that's what they're made for, look at how pretty the signal is. That's what a PDM should look like. Look at that. Now the duty cycle is going up to 100. And then it's going to go back down to 0. That's what it should have looked like. So I have to figure out a proper load to make sure that when my PWM is being used to go inside my high voltage, it needs to be clean like this. We talked about this basically. We talked about this. Okay, so I put a needle inside this tiny form and filled with epoxy, and it was an epic failure. This is what I was trying to do. I put a positive in here. All the little green are electrons there. They want to grab this positive, and then they're being faked out to go up through this diode, and they can't come back. And then that leaves this epoxy here to be more and more positive, and it's pushing out these super powerful red electrostatic lines of force. And yeah, this is 20,000 volts. I got it up to 20,000 volts, and I was able to do it for 6 hours, and it did nothing. It did nothing. Yeah, let's see here. I think we're just about done. So if you're working with sand and you wash the sand, then the sand will take 5 days to dry. If the sand is not washed, it will take about 5-6 hours to dry. You could look it up. It's a strange phenomenon, but it tortured me. I put it by the heater and I stirred it and it wouldn't dry. It took 5 days for this little tiny cup of sand to dry. And that's because I washed it. And washing it, you remove something that lets it dry real quick. Yeah. So this guy was 6 hours dry. This guy was 5 days and still looked like this. Okay. Also got some new heat sinks to build those variable air capacitors that you see in Tesla Coils Inventions. So picked them up from Amazon. I'm stoked. To be continued. Let's see. All right. So I have a friend who he calls me little brother, and he's in his 90s. And this is a World War II super tall, super big Van de Graaff generator. And so I finally was able to get it running. And the sparks, he said the sparks will go as far as 18 inches. I'm only getting 2 inches, but I haven't finished putting the thing together. But I thought I'd share with it because I'm going to be using this as well. When I can get 1 foot, 18-inch DC sparks, I can use that for making electrets. Look at that. Motor is so old and a light switch. It's so crazy cool. So I was playing with that. The top load here needs to be connected. That's one of the reasons why it has such a low output. But all right. So with that, I will close and I look forward to your questions. And guys, thanks for listening.
That was really cool, Sean.
I appreciate that, guys. I really do.
Oh yeah, nice. I like the cherry bomb.
Yeah.
Even though it didn't work, you said.
No, it didn't. And I think that when I get down to understanding fields better, I think I can get it working. But yeah, Jarvis warned me, and so I had to try it. So what do you guys think, Nathan, Ben? Any questions?
I'm sorry. Go ahead.
No, go ahead.
Oh, we had a question earlier, Mr. Lanius or Jarvis and I, about which rating resistors are you using for that probe piece? 1 watt, 2 watt, quarter watt. What would you recommend?
They're 8. I think they're 8 kilowatts. You could buy 10 of them for, I want to say they're about $1 each. That's why if you get a screenshot of that, or I can send you a screenshot. I did all the calculations. You just got to solder them, 10 of them.
We're specifically talking about the power rating.
So they're 8,000 volts each, and when you connect 10 of them, they become 80,000 volts. Because when you connect resistors in series, they're additive. So if you have 2 8,000 volt resistors, it's 16,000 volts.
Maybe I'm not thinking the right term, but when I buy my resistors, I can buy like small ones that will fry easy, and I can buy the big fat ones.
So what you're referring to is wattage.
Yeah, the wattage.
A quarter watt will fry because it can handle more current. They're tiny. 5 watt would be large, or 10 watts big.
Watt rating. That's what I was trying to get at. Yeah, Mike. Okay, sorry about that, guys.
Yeah, no worries. And the thing about high voltage is it has almost no current. In fact, static electricity has 0 current. So it's all pressure. So you don't have to worry about the wattage. You just have to worry about the volts. And that's why these resistors just have the voltage.
Okay, so that makes sense.
Did you guys learn anything new about electrostatic fields? Because I had no idea how they worked.
Well, I learned when you shake up sand, you produce a little bit of it, right?
Yeah, that blew me away. And
Yeah,
I
that
do
was
that
cool.
all the time. I'm sorry.
Just saying that's cool, but I mean, is that because there's like crystalline structures in the sand? You think?
So everything has hanging out electrons, and if you rub them together, then one of them's going to have more electrons than the other, and boom, you have charge. And it's a voltage is what it is. And it's called the triboelectric effect. I don't like that word. Tribo is a word that means to rub. So just rub two things together, and one's going to have more electrons than the other, and that really speaks to it simplifies the mystery of static electricity.
So it's triboelectric, not piezoelectric. Okay.
So piezoelectric is a pressure on a piece of quartz, and it creates a voltage, or a voltage to a quartz, and then it has a mechanical movement. So
So there's a
yeah,
pressure versus like a rubbing.
yeah. So if you push a quartz, it'll voltage on you. If you voltage a quartz, it'll push you. Yeah, that's all right. Well, let's look at the comments. Let's see here. Boy, a lot of happy people in the comments. Lots of love. Thanks, guys.
Yeah, you did really good, Sean.
Appreciate it. Let's see here. Coat Creative says, Master Lord of the Plasma, thank you. Mr. Lania says, we love you. Hey, love you guys. Coat, laugh out loud. Let's see here. Ben, lots of love. Thank you, sir. Thin wires, good to know, Mr. Lanius. Yeah, that was interesting to me too. Working with fields, you want to get a strong field. You really want to go with a thin wire. That was fascinating, and it makes sense because there's no current. So you put 1,000,000 volts in a piece of wire that is thin as a strand of hair. It's 1,000,000 volts of a static field. That was really hard for me to bend my head around. Was, oh, that doesn't make sense. You would need a thicker wire for 1,000,000 volts. No, because it's just pressure. And by the way, 1,000,000 volts on a little hair piece of wire. Oh my goodness. All the hair would raise up on your whole body. Oh, you'd feel it all right.
Oh, yeah. The whole room feels it probably.
Yeah, exactly. All right. Let's see here. Oh, no, sorry, that doesn't pertain. 8th Center says when he connected a wool strand top to tip, it blew him across the room.
Wow.
Wow.
Let's see. Just a lot of back and forth, which is good. You guys are learning. Lots of learning. Good job. So what surprised you the most, do you think, Nathan?
To be honest with you, it was that sand, because you can put it in a tumbler and just get crazy stuff out of it.
Yeah, exactly. It's I always go around the room and just connect things, or I'll just build something real quick that spins and I'll hit it and it has a tone, and I'll run some electricity through it. I don't know. I feel like Nathan does stuff like that too.
I use my lunch.
Yeah,
My
exactly.
burritos is that. A hot dog.
Exactly. And then and that's how I got to the sand. I'm like, oh, can I shake this sand? And I'm like, what? It keeps going up. It's totally insane. Totally. It was encouraging to me because I feel like I'm at ground level now, where I can now start building massive fields.
Nice.
And
Imagine you have one of those portable lights that you have to crank to power up. Only instead of it has sand inside of it, and you're just pushing it in a wheel.
Oh, that is such a cool idea. Oh my goodness.
I wonder if it's possible. If it's possible, that would be really neat, right?
Ben's gonna get a hamster and put it on the outside of it.
That's right.
Oh my god, that's so funny.
The squirrels outside are in so much trouble. They're gonna have little squirrel wheels, and he's gonna be taping it.
What do your lamp run on? Batteries? No, hamster food.
That's right. What's up, Mike?
Hey, Mike.
Oh man.
All right, so eighth center says it's agitation, electrons smacking into each other, the ones beside it causing a transfer and build up of potential. Yeah, that's exactly it right there. Mm-hmm. Shaking that sand, and some get more electrons than the other, and the whole thing becomes an electric field. Meticulous, Sean, thank you, appreciate that. Let's see. Yeah, Jarvis agrees. This is the ground floor of starting to build electrostatics.
Nice.
Stefan Drysdale says bleeding of excess energy in the desired direction of flow, i.e. corner to corner or end to end, or advanced corner to bifilter, configuration towards the center of the plate, for example. Nathan, you want to take that one?
No, you can take it.
Well, bleeding excess energy, I do know. So one of the things about when you're making charges on everything, creating electric charges, is they bleed away. In fact, I was charging high voltage capacitors. I took a ceramic 20,000 volt capacitor. I charged it to about 3,000 volts. And then I used my electrostatic field, and guess what it emanated? 3,000 volts. And that was really good for me to understand. Number one, a capacitor is an electret, but as I was looking at my electrostatic meter, it went from 3,000 volts down to 2 volts within about a minute. Why? Because it's bleeding out.
Yeah.
The thing about an electret is it doesn't bleed out. And that's the key. So if you were to say, okay, permanent magnet has a permanent magnetic field, a capacitor only has a temporary electric field. An electret holds those molecules in place, and it becomes a non-changing, non-bleeding out electric field.
So you don't get zapped, right?
You don't get zapped, but you'll get the hair up on your arms.
Yeah.
And you'll get all the tingly. You rub it across your wife's wool sweater, and it'll probably stick, depending on how heavy it is. And stay there all day.
Asking for it.
I know, huh? Right. Let's see. I've never found yet a Fresnel screen, forever looking for a nice giant one. So eighth center, that's one of the goodies of the rear projection TVs. You can easily get 2, even 3 giant Fresnel lenses. And so if you frame this 60-inch Fresnel lens and make a little wooden stand for it, you put it out in the sun, and you can cook anything. You could grill steaks. It's all sun power. You can cook pot roast. Mm-hmm. So awesome. You'll get 2 or 3 of those in a rear projection TV. So I'm glad you brought it up. And yeah, it's a giant magnifying glass, but it's real thin plastic, so you can just stick it in the back of your garage, but pull it out when you need it.
You should record a video of you cooking some stuff with it.
Yeah, I think when the snow melts, it would be. It'll be. Wait a minute, I don't know. Thank you, Ben. I haven't put it up here on my list.
Sean's going for a weenie roast over there. He's gonna blow him up.
A Fresnel lens roast.
Yeah, barbecue, neighborhood barbecue powered by the Fresnel lens.
Yeah, A block party, you know. Where's your barbecue? It's that big square thing.
Yeah.
We're cooking with science, guys.
Yeah. That magnifying glass? Yeah.
Yeah, it's a little slow, but it's cool.
Yeah.
Actually, if you tune it in right, you can get it to be really hot.
Oh yeah. You can melt metal with it. Oh yeah. That thing is crazy.
They used to use that in ancient times as a weapon, right?
I'm not sure.
Not with the same lens, but they used to redirect the sunlight.
I think they had sundials definitely. So I know that the Aztec ruins and the Mayan ruins and probably the pyramids all had sort of.
Well, I'm specifically talking about the Romans. I believe they used the directed sunlight to burn each other's ships.
Mm.
Oh yes. Yes, good point. I've heard of that too, actually. Let's see here. Am I at the end here? It surprises me that I picked up 2 rear projection TVs and for free, and they're still out there. It's just people don't think they can throw them in the garbage, which they can't. But
what size screen did you say you had?
50 or 60.
50 or 60.
They weigh like 100 pounds. They're on really nice wheels. Yeah, and there's just a bunch of cool heat sinks, some pretty intense transistors. You hear about those horizontal deflection transistors that Gerald talks about. Yeah, you get a bunch of those.
So hold on real quick. What was the resistance value of the 10 resistors? I think he's talking about your probe.
Half a gig of ohms, 500 million ohms. Oh, it's nuts. It's actually 490 ohms because your multimeters are 10 mega ohms. So if it's 490 mega ohms, add the 10 mega ohms from your meter, it becomes 500 million ohms. And then that gives you, your meter will read up to high as 600 volts. And so your meter is 600 volts. And when you're measuring things, you'll get a maximum of 30,000 volts. So if you see 600 volts using this meter, this probe, I mean, then you're seeing 30,000 volts and it doesn't harm your meter or your oscilloscope. Isn't that crazy?
Yeah, that's awesome.
All right. Steven says, thank you, Sean. The safe read setup you figured out makes me think about nano exfoliated copper or brass extra, and if you set up as an effect on readings of such metals, alloy, ferrous, and non-ferrous. Interesting. Thanks for sharing.
There was a question about sand. Hold on.
Sure.
Was that ionized sand?
Yes, you're ionizing the sand. Yes. And ions, I always believe, have this big mystery. And all an ion is you have this really happy molecule, and then another molecule says, hey, I'm going to steal your electron, and they do. And so now this happy molecule is sad because it doesn't have an electron. So the sad molecule is an ion, positive ion. The molecule who stole the electron is a negative ion. That's it. It's not harder than that.
Yeah, what a punk.
Yeah. Negative Nancy.
Oh, someone asked what's the proper name of the dyslexic font. It just said dyslexic font in my my software Bible. And I couldn't believe it because the way the font is, it's like art. The words are spaced away and the words look like symbols. And I'm not sure if you guys know this, but dyslexics see things in symbols and it's hard for them to interpret. So it's an interpretation thing. So anytime I'm a very slow learner, but I just stay with it. And that's the key. I'm the tortoise. I'm definitely not the hare.
Well, the tortoise beat the hare in the end.
That's true. That is, and that encourages me because people think I'm dumb when they first meet me. Oh my goodness, most people think I'm dumb, and it's just because I'm slow on the uptake.
Well, and that's one of my favorite stories, because that teaches an important lesson, you know.
Yeah, exactly. I don't know how many people have met me, and then a few months later, they go, "You're a completely different person," and I don't be like, "Okay." The last guy they met, idiot.
Yeah, Cody asked, "Are you left-handed?" I believe
I'm
you are,
left-handed.
right? I know I am.
I'm a left-handed dyslexic. Mm-hmm.
We're both left-handed. Who else on the Fringe team is left-handed?
Not me.
I was in high school and they put me in the special high school because I was working full time and I didn't have a lot of time to do my homework. And everybody that was there was left-handed, and about half of them were dyslexic. I thought that was interesting. It was the loser high school.
I spent a lot of time in those type of classes. I just hate reading.
Oh, I love reading. I'm just terrible at it.
Joe says he's got 3 left-handed kids.
Oh, that's incredible. That's rare.
Yeah. That's cool. I didn't know he had that many kids either. That's cool. Big family.
Yeah. So John,
I grew up with a big family.
Say again?
No, I was just saying I grew up with a big family. We had 6 siblings.
Oh, wow. Yeah, I got 4 kids. Nathan, you have like 11 kids, don't you?
No. I'd be balder than I am now. It's bad enough it's gone gray because of them.
There'd be no hairline, huh? I see extra gray in your beard, so you must have a daughter too.
Well, see, it used to be like here, and then now it's way back here from 5 kids.
Yeah, 4 head to a 5 head.
Yeah. They started counting the lines on my forehead.
Yeah, we're all getting old, brother. I'm on
What's
the
up,
senior
Phil?
Denny's senior menu today, or this year. All right, John says, I want to try an oil-filled transformer of the high voltage generator circuit. Even a very small one would benefit from the oil. You can push it way beyond its specs. So there's always in these high voltage devices, there's always these little high voltage transformers. And I don't know if you've ever bought the high voltage transformer kit that didn't have the black tube over it and filled with the black epoxy. Have you seen that before? Those little kits, Nathan, Ben?
I have not.
I did not see the kits, but I ran into some mineral oil, and that's nasty stuff. It doesn't come off of everything.
No, it's horrible. So people will say, "Hey, we can push your transformer in some oil," and those transformers from China are horrifying. They're terrible. So unless you get a big one, and maybe from a larger one, not a big one, but bigger than those little thumbnail-sized ones, and then you submerged it in oil, probably. But then, what do you do with a transformer in a cup of oil? It becomes sort of for me, I'm clumsy, so yeah, oil works. I'm just not a big fan of it.
Yeah, you gotta be careful. It just seeps into everything, like all your holes.
Grease and lubing your holes.
Creative Studios said to my big airplane hangar, "Oh my goodness, junk heaven."
Yeah,
Yes.
that was nice,
So
man. I wish I had a garage that size.
and it's funny because I have a 5-car garage attached to it. So
Oh,
this is just a
keep
giant.
bragging.
It's yeah, and the reason why it looks so horrible is we have our kids and they moved out, but they left a lot of storage. And as they move apartments and change, so the whole area is 2,200 square feet with a 15-foot ceiling, and maybe even taller than that. And it's kid stuff, grown kids, 4 adult kids, junk. So I was hiding the messes. You got some of them, but it's a fun place.
Nice.
Yeah, well, there's a story behind it if you have a real quick minute.
Yeah, go for it.
So we had 4 kids in our first home, and it was very small. It had 1 bedroom. We love that little home. It's quaint, but we had 4 teenagers on our hands and 1 bathroom, my 3 daughters. So
wow.
it was, yeah, you would have to put it on the schedule to use the bathroom and, a week in
That's
advance.
terrible. Yeah, a week in advance.
You got the families lining up like in a line.
Oh,
Yeah, exactly. Pull a ticket like you're at the barbershop and wait. So my wife and I are looking at these little track homes, and they were building some in the area, and they were in our price range. They were modest. Middle. We were middle class. I was just a junior computer programmer, and I had gotten lost in the city that we were looking at houses by myself. I was lost. I came across this house, and it's this 4 lots is houses on, and the house is so large it takes up 3 lots, and so it's massive. And so I just took a picture of it's for sale. I go home, my wife's on her laptop, and she's looking for houses, and that same house was on her laptop, and she had told me, yeah, there's no way we're going to get a house like this. And I said, sweetie, I just got lost and ended up there. What do you think the chances are? She's like, oh, it's a God thing. So we went there, and it was owned by a luxury builder. And so when we came in, the living room was as big as our previous home, and it was mahogany floors. I mean, they make instruments out of mahogany, not floors. And as we were walking around, we were laughing. Oak floors, ginormous, 11 rooms, high ceilings, 3 wings. There's 3 wings to the house, so it has 3 furnaces. And we just thought, we laughed because we knew we could not afford it. No way. And then at the end of the tour, the guy goes, I'm offering this. And it was right after the 2008 housing crisis. We didn't really know. We were young. We weren't following the news. And he had $1 million buyer, and he fell through, and he had to sell the house rapidly. So he offered us the price of the little track home that we were wanting to buy.
oh, nice.
So we got a mansion for a very, very low price.
That's so awesome.
You can't even get a 1-bedroom apartment for the mortgage on this house.
I love hearing good stories like that, because you got a big family. You need a nice house to take care of your family and their needs and stuff. So that's good to hear. That's very heartwarming.
Thank you. Totally blessed. 100%.
Like something good came out of that crash,
Right. Exactly. And I felt bad for the guy, but we didn't lowball him at all. We thought we were just going to leave with that was fun. We were in a rich person's house. We'll go now get our little track home. And it's you can't get a 1-bedroom apartment for the price of our mortgage. So it's crazy.
Yeah, that is awesome. I love hearing stuff like that.
I appreciate that. Right. So Creative Studios, I tend to stop at 10,000 grit over obsession and sword polishing. Okay, thanks for sharing.
Sword polishing? I'm not going to touch that one.
No.
He's just shaking his electric,
Yeah.
getting his sand warmed up.
So Mr. Lanius mentioned oil-filled transformers to me to save cost, and yeah, well, I mean, if you want to save that cost, I'm all behind you. I can't have a cup of oil somewhere that won't spill. So, all right. We got somebody that's saying hi from Venezuela. Well, thank you. Great to
Hey,
have.
Yeah, hello.
yeah, that's awesome.
Yeah. Un saluto da Venezuela. Maybe it's not Venezuela. Maybe I don't speak Spanish. Sorry. I'm Mexican and I don't speak Spanish.
Oh.
So my friends call me Z Mexikanski, my Polish friends, which means the evil Mexican. Yeah.
Nice.
It's funny. So John here says, oh my goodness, just a mineral oil bath would do. So Aaron had to halt his hobbies. Oh, I'm sorry. That's no fun. John says linseed oil. I heard was good, but need to boil out the air. Yeah, I
Vacuum
meant.
it out.
What's that?
Vacuum it out.
Yeah. Oh, there you go. Vacuum chamber.
Yeah, you're going to need to if you get that oil in there because every time you get a bubble, it's a hot spot.
Interesting. Now they're talking about polishing titanium knives. Okay.
Okay. Yeah, they're polishing their swords.
That's cool. Oh, toothpaste. I always use toothpaste to polish things. And here's a trick too. If you spill acetone or you get a smudged piece of plastic, it gets like a rough spot on your plastic. You can actually polish it with toothpaste and your plastic will look like new. All right.
Oh, man.
Leather sofas.
What? First you polish it with toothpaste instead of toothpaste after you polish. Now you got leather sofas. Wow. Such an adventure, Sean.
I'm spurring very creative conversations here. Oh, Ben, you like the little cherry bomb? Yeah.
Yeah, it was adorable. I can't wait till you get one that's working. That's going to look awesome.
Know.
All right.
Oh.
I know you like reading comments all day, Sean, but we got to zap.
Yes, sir.
So I don't even know if my computer will handle this right now.
Oh, boy.
Let's see.
He's got the circular attachment.
You need me to turn the lights off or you guys can see it?
Barely.
Okay, hold on. Computer didn't go off. I'll be right back.
Okay. So Nathan has a therapeutic wand, and it's the same one I had that converted into a handheld Tesla coil. And so what he's going to do, he's going to modify it and show you guys how to modify it so you can have a handheld Tesla coil and be able to walk around your house and just electrocute things, because that's what we do.
Okay, let's see now. Ooh, there we go.
Oh, yeah. That's awesome.
Make sure we turn it up. You wouldn't want to have me shortchange you on the show, huh? So, yeah, Sean got me this and sent it to me and told me, oh, yeah, just go ahead and use it. You'll be all right. So, you can see the spark. Oh, hold on. All right.
This is better than Electro Boom.
Oh,
And by the way, this is how it's designed in China. You're supposed to do this, and it makes your skin smooth.
No, it's not.
It's supposed to get away wrinkles.
Oh. Ooh. All right.
That's awesome.
That's just torture. I don't know why these people would do this.
Let's give Nathan a round of applause for taking one for the team. That was awesome.
Oh, he's gonna comb.
Oh, he's got one more attachment. Oh no.
He's got the electric comb.
He's got the encore going on.
Oh, didn't get it that time. Oh, I got it that time. Oh. Oh, you can see it hitting.
Yeah, you can see it.
I'm gonna have holes in my beard tomorrow.
Either that or you're gonna have the smoothest skin in your family.
That's right.
Oh.
Wow, you look young.
Yeah, I look young, all right. All right, big forehead time. Make sure it's turned up.
Tesla coil time.
Oh my god.
No. Oh, that's all right. Oh no. Okay. My computer hates me. All right. Oh. All right. I'm gonna turn back on my light, Sean, and then we're gonna build this thing. Oh, my face is gonna hurt. It's gonna hurt worse than looking in the mirror. All right, here we go. I'll be right back.
I know what you mean, man. My mirror hates me. So we got some more comments about ionized quartz sand. I never thought about that. Quartz sand sounds really interesting to me. It really does. I was really hoping to get some of that piezo effect with quartz sand.
Okay. All right, made it back.
We had to give him a moment to recover from that. That's
all right. So I'm just gonna go full screen so I can show you what we're doing here. Sean, just direct me. So there's a little screw right down the hole.
Yeah, remove it.
Let me make sure I turn it off. That wouldn't be fun.
So thank you guys. More love in the chat.
Hey Lulu.
Hi Lulu. Hi Mike. Oh, Joe on too? I thought I saw Joe. Hi Joe.
Yeah, Joe's here. Hi Joe. Well, hi again.
Hi Jar Jar. Jarvis, Brent, Mr. Lanius. The man of many names.
Everybody's here. Mostly everybody.
Okay, Sean, it's not coming apart.
No, you need different screw head. Oh, you got to just twist it. Don't be afraid. Wait, can you show me the front? Sorry, show me the front. Okay, you have to cut that so it's flat. You have to cut that plastic.
This?
Yeah.
Cut it. You didn't say we'd be sawzall and stuff.
Yeah, sorry about that. So do you have a pipe cutter, a little like PVC cutter where you turn it and it cuts the PVC perfectly?
I do, but I don't know where it is. I didn't expect to do this.
Sorry about that. I thought you could clip it with clippers. No, you're gonna have to.
It doesn't pull out.
So the top part, I remember. Oh, I see what I did. If you pull off the back, have you pulled off the back with the cord part, the cord side?
No.
Have you twisted that?
You gotta twist that.
Yeah, and it should come off.
Okay, this thing is not working for me at all, Sean.
Can you show it on the screen? Because I want to compare it to mine. I mean, it looks the same. Yeah, my back's part. Oh wait, no, kind of doesn't. Can you show me on the screen and turn it? Oh, you have a completely different model. Oh my goodness, I'm sorry. Yeah, because I have the one that it's white, looks just like yours. So if you look down the shaft, after you took out that screw, if you can look down the shaft or show it to the people.
That's where I need to put the needle at. No, I got this. You guys go ahead and talk for a minute. I'll be right back.
All right, cool. I'll go back to the comments while Ben sings.
Oh, say, can you see by the dawn's early light?
So, Mr. Lania says something interesting. Electrodes are like solid plasmas since they are permanently ionized. That's a really good point. I never thought about that. But an electret, in a sense, is a plasma ball, a permanent plasma sphere. That's just crazy to think about.
Yeah, that's insane. And if you've seen the videos of Sean using the little handheld Tesla coil, it can actually show you, and this is the thing that I liked about it, the pathway of electricity and how it loops back. And it's, you know, how it's choosing the path of least resistance for itself. And you can see that happen in real time.
Yeah, it's you can get that little Chinese medical device for $30 on Amazon.
Mm-hmm.
And then that's it. You're ready. Now, you don't need these brass tips that screw in perfectly that Nathan and I use. You can put in anything in that tip, but a little bit of modification, and you got a handheld Tesla coil. I'll tell you what, I showed you, but I shock everything. I'll look at my messy bench and go, I'm just going to light it up. And you're right. The electricity will come out in some strange place, and it's so interesting.
Yeah, like you'll notice it gets attracted to a certain materials or objects.
Right. Yeah, exactly. All right. Someone said they saw someone melting a rock with a Fresnel lens.
Really?
I believe it.
That's cool. Huh. Yeah, molten rock.
Eighth Sinner saying the videos of people forging under solar heated materials. It's interesting. Yeah. The having a, what is it, a 5 foot magnifying glass. I mean, you're gonna be able to create some heat.
Yeah. Be able to forge some fire and steel with that baby.
Right. So John says, remember to keep the dipole, use the proper diode array, and you can harvest the entire electrostatic potential. It's interesting. So the electrodes that right now that exist right now are in sensors or microphones, and so they're dipole, and the dipole is just a fancy word for two poles. So magnet's a dipole, has north and south.
But a circuit also has a dipole too, because you have a positive and negative terminal.
Exactly, and a positive and negative charge, and so on.
It's all self-similar. I was gonna say, but yeah, it's
right. So it's nothing really fancy. It's just another word for saying it has two poles. But what's unique about Brent Jarvis's patent application for electrodes is that he posits, he theories that you can make a monopole and you can make a magnetoelectrode. So a permanent magnet, permanent electric charge field.
And you're talking about like a true monopole.
A true monopole, which is, so for example, a true monopole would be an electron flying through space, because it's just negative.
No, that's exactly, that's a very good point.
Right, exactly. So for us to get such a powerful charge of one charge, almost eliminating the other, I don't think it's possible to eliminate all of them, but eliminate them so much that all you can read is one pole.
And Jarvis also emphasizes it is a dipole unless it's an open circuit. So Maybe you can follow up with an elaboration on that, just to give me some context, because I'd like
Sure.
to learn more, honestly.
Yeah.
When Tom Bearden always talks about don't destroy the dipole, I'm like, okay, so we have a positive and negative, terminal for your circuit, but what does that actually mean? Don't destroy the dipole. I've always
Sure.
been curious what he meant by that, and I'm trying to simplify it in my head.
Sure. Sure. So imagine a magnet. Okay. You've ever seen a magnet with the negative and south poles?
Mhm. Yeah.
And do you know how to draw the fields and how the fields come out of the North Pole and bend
Yeah,
over
they're
to
kind
the
of like
south?
heart shaped at the top.
Correct.
Mm.
Exactly. So that north um, field, that north field pointing toward the south field,
Mhm.
that field geometry, that structure, is what they're referring to not collapse. So,
Oh,
and so now think of a piece of copper wire with electricity running through it becomes an electromagnet. So the copper
right.
wire becomes a magnet, so it has its north and south pole. Now that magnetic field around the copper wire then is called a dipole. And what they're saying is figure out how to get electricity without collapsing that magnetic field around the copper and the coils and the device. So keep that electric field, that magnetic field, that north and south. Don't touch it while getting energy, extracting energy from the system.
So does that mean avoid collapsing, like pulsing the coil, or is that something else?
Well, pulsing is just turning it off and on.
And that's going to collapse the electromagnetic field, but that's not going to disrupt the underlying geometry of it when it comes back on, right?
It'll just shrink and grow at its same geometry.
But that's not. Would you consider that destroying it, or that's just pulsing it on and off?
I mean, if you make an magnetic field disappear, I mean, you can call it whatever you want. I mean,
I'm just
just
trying
try.
to figure out, like, if Tom Bearden was talking about like avoiding pulsing electromagnetic coils, like, or if he was talking about something else.
So, what it is that what they want to throw away or not dissipate away in a generator as it powers something.
Mhm.
The emphasis is on extracting the stuff they're throwing away or don't want or make their systems to not want. And so part of that is to maintain this magnetic field, the dipole, while then extracting
The back
usable
EMF.
energy
Yeah.
from it.
Okay.
Okay, Sean.
Oh,
So I
he's
don't know
ready.
if that helps. I'm a new fringe scientist with you, buddy. So
It's putting me on the correct path, I believe. So I appreciate it. Let's see what Nathan's got. You got
oh
is that the
yeah,
bottom or the top? Oh, you got the top off.
that's it.
I got the needle and everything in there. Do I need to ground anything?
No, but now there's something you have to be aware of. When that thing's plugged in, it always has power. Okay, so right now it has power. So if you
Okay.
can get out your multimeter and connect it to one end to ground, one to the tip of that, and share us the voltage, you'll be surprised.
Okay, I don't have a lot of ground in this area, Sean.
You don't
I've
have the outlet?
well, it's like far away. I'm on an extension cord right now just to have this thing plugged in.
Oh no. Okay, no worries. So
I do have one of these.
what's that? Oh yeah, yes you do. So now you can run. Do you have a large one, or is that your biggest?
Oh, it's the biggest one I can find right now.
Zoom in your camera on it, and then run that needle across, and you'll start seeing fractals.
Okay,
You'll start seeing what electricity likes to do.
gotcha. You guys do your thing. I'll be right back.
Okay. There's so many
So
good
Bob,
comments.
you said what?
Sorry,
I was just saying, Bob John said, Bearden argues that the conventional electrical systems we In conventional electrical systems, we kill the dipole by consuming the potential difference through resistive loads rather than maintaining the dipole and tapping into it. And I did a follow-up question because that makes a lot of sense. And especially when you think about the ABHA coil system, the Rodin coil system that we have, it's not using a resistive load. It's using a load that's actually resonating with the rest of the system, with the source and the coil and the capacitor. So it's not resisting anything. It's in resonance with it, which makes me think, well, maybe we aren't destroying the dipole in that case.
So because you have alternating current, you're building and destroying the dipole. I think
so right away alternating current is not the way to go. You want to go with direct current?
I mean, what I've listened to the Bearden lectures, I need to listen to them again.
Yeah, same here.
Yeah, but my understanding it would be is if you have a dipole to keep it up, I don't know what AC is, positive polarity, negative polarity, positive polarity, negative polarity.
Right.
Poles are switching.
That makes sense. Huh.
So maybe look at Nathan.
He's all ready to go. So what exactly do we have to do to modify this thing? You said it wasn't very hard, right? It's pretty simple.
You just cut the tip off like he did. So you see the black part? And then now look at that handheld Tesla coil.
Oh, that's it.
Yeah.
Wow.
It's
Look
frozen.
at that.
Oh,
There you. So it's hard to kind of see because the board is facing you instead of us. Can you lean the board toward the camera?
Oh, there we go. Oh, wow. Look at that.
So it has the XY coordinates. It travels up and down.
Yeah, you can see it going up and then back, looping back into itself.
Touch it. Touch the needle to it, Nathan. There you go. Can you see it better?
There we go. Yeah, you see the loop. It's so cool.
Now you can move the needle. Slide the needle across it while touching. Look at that. That's so interesting.
Yeah, I've never seen anybody else demonstrate this before. It's so cool.
And throw a pack of them down, and you'll get this pattern across all the boards laying there, because it'll jump from board to board.
Or maybe if you have components on the board too, you think it would show you the path of the circuit?
That's an interesting question. That's a really interesting question. I don't think so.
Maybe. I don't know. I guess it would. Yeah, it might depend on the components, I guess.
So these holes on the circuit board, they're not connected to anything. So electricity is jumping from hole to hole. Okay.
That's actually mind-blowing if you think about it.
Yeah, exactly. If you were to ground the other side of that board, it'd be even more tense.
See, I didn't even read. That's something that snapped in my head. These holes aren't even connected.
Right.
They're separated by the silicon, and that's an insulator. So
yeah, it's a fiberglass, I think. Fireproof fiberglass, I think, is what they build the PCBs out of. Super resistive. But yeah, it's jumping across the holes. If you were to have solid, it would just kind of disappear into the conductor. You wouldn't see it.
And you wouldn't see it.
Yeah. Now throw a big pack of screws and nuts and throw a bunch of these boards and then start electrocuting, and it'll always amaze you the paths that it'll take. Like we talked about earlier, sometimes something behind me will be buzzing. It's because the current got all the way behind me onto some metal object. And the thing is, this is not deadly. This is enough. You don't want to touch it. It'll hurt you. It'll hurt you more like this than what he was doing with the medical device. Look at that. That's about an inch and a half. So that's 20,000 volts plus. That'll hurt you. Now, it won't kill you. Not at all won't kill you. It's 185 kilohertz. At least that's mine.
going on?
Invite your buddy over and then be on the other side of the door with that thing touching the doorknob.
Yep.
Look at that. Look at that. It sparks and then it goes down through the thing.
Wow. That is so cool.
Yeah, what is that he put in there?
It looks like a brass.
Little brass thing that came with the kit.
Hmm.
Hold on, I got a couple more. We gotta find out here.
Wow, that's really cool. Oh, wow.
You
A
can hear it
handheld-
too. Hold on, let me put my other headphone in.
A handheld Tesla coil for $30 on Amazon. Try buying a handheld Tesla coil. I think they're like $150, $100.
I didn't even know they were on the market.
Well, I'm using it against its purpose. It's a Chinese healing device, so that's why it doesn't stand out. Did you get zapped?
No.
If you had a ground clip, or could you clip your board to a piece of metal?
Maybe. Hold on. Let me see what I got in my junk drawer here.
All right. I'll look for comments. So Ben keeps us happy. A lot of good ideas about quartz sand. I'm going to pick up some quartz sand. I have to now. I need to talk to Joe about, he's like a geologist. I'd like to talk to him about what would be good to ionize.
I know a geologist. I could talk to him too.
Yeah. Look at that.
Peter hates this.
It sounds like a synthesizer or a cheap phone alarm.
Okay. I'm gonna blow up something. Turn this thing off. Hopefully I don't get zapped in the process. Oh.
Sorry, Co. I won't repeat my stupid comments.
Oh. That stuff is not zappy. All right. That's good.
One thing I love about Nathan, he's fearless. No fear.
Well, you gotta try it and find out. That means you're gonna get hurt a lot.
Yeah, one of these days he's gonna show up with half of his beard burnt off. Or like he turns on the camera and like his beard has just got like one strand on fire, just slowly sizzling up.
You never know. Let's
Yeah, John. Yeah, matter is an electorate in some ways. Everything is an electric field. Everything is a magnetic field. That's why they'll just say electromagnetic, because Maxwell's equations and how they're intertwined. So, but I prefer saying magnetic waves or magnetic fields and electric fields. Otherwise, it's so confusing.
All right.
That was awesome, Nathan.
So I just grabbed the tool and cut it off.
Oh, smart.
Yeah, it's in a couple different parts. So
Yeah, that's that holds the little glass tubes.
yeah, so real quick, let me show you this. Hold on. Let me get my. Okay, sorry. Let me show you this. All this is, by the way, I did tape it, Sean.
Uh-huh.
I won't come out now. You can see right here, I thickened it up with tape.
Yeah. Yeah.
So that it could stay right there inside that area.
Yes, exactly.
So in those
And
little
show people the back.
the things, huh?
Show people the back, because you can control. It has a potentiometer. You can control the high voltage.
Oh yeah, how much you get zapped? Usually it's on full blast when I play with things.
And the
Why
thing
not?
now is, you do not want to get zapped with it now. Okay,
Oh.
you've increased the pain on that big time.
Oh, great. More pain.
Yeah, I was gonna say, because that thing's bit me a few times.
It got you and you're all right?
Yes, it won't like stop your heart or anything. It'll just make you wish you didn't touch it.
Oh.
It's just a little more pain than what you experience, which is not fun.
I was wondering if it would singe the bottom of my beard if I touched it. Hold on. All right, guys, throw up the fireballs. Here we go.
Uh-oh.
What do you
Put 911 on speed dial.
Yeah, I got a pair.
No, don't do it.
You can see it's on.
Ah! Oh, no. Oh,
No, not got me yet. It will.
it's on full blast.
Yeah. Oh, you want to make sure it's on full blast, huh?
Yeah, full blast got me. It bit me a few times. Oh no.
I got a long beard, so I'm lucky.
I tried on my hand, not my face.
Wow. Gotta have a pair, man. You gotta give it a try.
I'm a bear. Ouch.
Try it and find out. That's the way it works.
Ben and I don't have a pair. We're not going to do it.
I need an extra pair. That's what I'm gonna need. Extra pair of pants.
So Tim Johnson said that these handheld Tesla coils can't be run for more than 10 minutes. I ran this thing all day.
Yeah, this one's good. No, you're good.
I ran it all day. Doesn't get hot or anything.
Oh, nothing but good, clean fun right there.
So you don't have any place to connect a ground wire?
Sean, I am literally like in the middle of an island right now because my computer and stuff, I had to move it because it likes to go off when I put high voltage around it.
I see.
So, yeah, you can see the extension cord right there.
So I'm just trying to think of a way. Do you have a light bulb handy where it has two wires coming out?
No. You need something to zap? Is that what you're trying to do?
Well, two things. To zap a light bulb would be awesome. And then second, when it's turned off, I wanted to show you that it has a little leftover voltage when it's off. That way I didn't want to leave you thinking when it's turned off by the potentiometer, when you turn it off, it's not 100% off.
Well, let's see.
I wanted to show you that if you could touch it to a diode or something.
To zap or not to zap? That is the question.
What can I zap today?
Lights in it.
Something with lights in it. Well, I could get a 4-foot light, but I don't think it's going to do it.
Like a fluorescent tube?
It might.
It might. All right, let me give me a second. Grab one.
Awesome.
I think it might. I think it might excite that gas inside that fluorescent tube. I don't know. What do you think? Chat, what do you think?
Yeah. Put your comments in the chat. I think it'll light it up. Not bright though. They might surprise us. People are having fun in the chat. That's what I can see. Good news.
You know he's gonna zap this bloody burrito.
Oh, that's funny. Thanks again, guys, for all your kind words.
Yes, the chat is amazing.
Oh, it did. It turned on.
Yeah, look at that.
I told you that's a little train that could.
Oh, it got my hand. Hold on.
Yeah, it's a little train that could.
Oh, yeah, it zapped your hand. My computer hates this thing.
He's like, F you, Nathan.
Oh, it got my hand again. Oh, when you touch it, it zaps you. Oh, how about this?
It's tiny but mighty.
Oh, look at that. The black light.
Thanks, Co.
You should get one of those plasma balls and put it next to a plasma ball. Like those novelty balls.
Put it right to your novelty balls, huh? Okay. Get right on that.
He's going to take that out of context for his Star Trek episode.
So, Nathan, you see that extension cord? You got to do it
Yeah.
with the lights out. You got to do it with the lights out. We can't see it.
Oh, okay. Hold on. Give me a second. I can do that.
Nathan Sean song. Sean song. What's a Sean song?
Sean song.
I've not heard of it.
Sean song.
Sorry, Joe.
We shall make a Sean song.
Nathan will have to. Nathan, what's the Sean song?
There we go.
All right.
Nice. Look at that.
Do you have a glove on the other hand?
Wow. That's bright. Look at that.
What is a Sean song? I have no idea.
Hold on.
That's
Nathan
pretty
knew
bright.
the Lord of Plasma. Nice. Nathan, hold it by the other metal side.
No, don't hold it by the metal side. I'm not doing that. You talk me into that stuff. I know how electricity works.
So, Nathan, you know how your extension plug has 3 slots?
3 holes. Yes, it does.
3 holes. The ground hole, can you put something in that and use it as a ground wire?
Sean, I only got 1 spot. So either this gets plugged in or I start plugging holes.
Oh, I see what you're saying. I see what you're saying. Sorry. I
It's
get
all
too
right.
excited.
Oh, trust
Whole
me.
lot of holes.
Yeah, filling holes over here.
Do you have a little box of LEDs? A handful
man.
of LEDs?
I tell you.
Oh, or maybe some neon lamps. Those little tiny indicators.
Yeah.
I don't use those. They usually fry on me.
The
Yeah.
neon?
I blow everything up, guys.
He goes through a lot of stuff.
His box of shame is the back of his pickup truck.
Yeah. it wouldn't fit. There's too much. Okay. I don't know. I don't have anything right now.
So what Nathan's showing is 185 kilohertz handheld Tesla coil that is meant for treating skin, getting rid of blemishes, causing hair to grow, and it's used as a tool, medicinal purposes in China. $37 on Amazon. And
Yeah, it also gets your neighbors to leave the house. Just tell them it's a good toy.
Double as a taser.
Yeah.
say, hey, hold the metal part when you turn it on.
No, I'm sorry, guys. I don't have anything here with me.
No worries. It was fun when you were treating your face.
Oh.
So Nathan, there was some chanting in the chat about Sean song. What does that even mean?
Oh God. I haven't had a chance to listen, but Brendan made a song for you, and I don't know
Nice.
if it's inappropriate or not. So I usually like to listen first.
Oh yeah, no. Is that Ian? Is Ian on? Ian's driving. He's driving home to Florida.
Yeah.
Ian said he'd be listening in though.
Okay, are you sure, Brendan? You're not getting me in trouble, because that's a lot of trouble.
Did he make the song himself?
I think so. Nothing copyrighted, no problems, no weird stuff.
No politics, no.
Okay.
Joe says he vetted it.
Oh yeah, Joe vetted it.
Okay, hang on.
But I don't know about Joe's vetting.
Yeah. Last time he vetted something, man, I got in trouble. Remember the Christmas song? He thought that was a great idea. That didn't work out.
Joe's like a knife. He'll cut you.
What, the song that you were singing?
Yeah. He said, no, it sounds great. Don't change a thing. And I'm like, well, I asked him, can you make it sound better, right? And he's like, no, we're good. I shouldn't have listened.
Oh my
All
goodness.
right. Here we go. Let's see. Is the volume up? Volume is.
I like the start.
Through the smoke and the sparks, as the currents collide, Sean Calderon emerges where the lightning resides. The Lord of Plasma, the arcane king, with Tesla's secrets, he makes the coil sing. The pyramid crackles, the Death Star roars, electrons unleashed like celestial wars. Nathan and old man builds the stage of the flame, with the crew in the chat. They all shout his name. Bow down, Calderon speaks. His voltage flows, the strong and the weak. Sparks will dance, guys will turn. It's
Awesome.
It's your turn to learn. The CVS driver hum.
Awesome.
The pulse of creation at his command. From circuits unknown, his wisdom flows. A god among mortals where the plasma grows. Disciples gather, their eyes aglow. In the chat they praise as the currents show. Lightning arcs and the silence breaks. To Calderon's will, the ether shakes. Bow down, Calderon raise. The Lord of Plasma, who wields the flames. Sparks ignite, the air is torn. In this storm of power, new worlds are born. The coils erupt, the void replies. A Tesla born him electrifies. Nathan's crew and the faithful cheer. For Calderon's lessons, they all draw near. His teachings echo like thunders roll from the ether's edge to the depths of the soul. He speaks of circuits, of power attained. Sean Calderon, forever inflamed. The pyramid hums with a sacred glow. The Death Star spins, its fury shows. With Nathan beside him, the sparks align. Old man builds a temple divine. Bow down, Calderon speaks. His voltage flows, the strong and the weak. Sparks will dance and the skies will turn. It's realm of plasma, it's your turn to learn. From the chat they call the disciples of light. Teach us, Lord Calderon, guide us tonight. With each arc a truth, with each pulse a path. The Lord of Plasma defines the map. Feel the crackle, the charge, the spark, as he bends the lightning to light the dark. Sean Calderon, the teacher, the flame, the one true master, remember the name. The coils of lava, the current flows free, the air alive with electricity.
Oh, that just shut off.
It's over. Wow.
Oh, that's awesome.
That is clever. I mean, well done. And who was playing that amazing solo? The guitar riffs were amazing. Good writing.
They got it from Sunyo, Suno, and they make music. You put in the words, and then they play the music behind it. If I'm not mistaken, I could be wrong.
Oh, it's still well put together. You still have a very good song, right?
Oh, it's really good. We're gonna have to get it as your intro when we call you on.
It's crazy. And who put this together?
Brendan did. So, Cote Creative Studios.
Wow, what an honor. I feel so honored. I'm humbled. I really am. You just made my year. I'm not going to say made my day. You made my year. I
Right on.
I don't know how I can even repay such a debt of gratitude. Thank you so much. Thank you so much. I'd love to get those words or get a recording of it for my wife. My wife likes heavy metal rock, so
Oh, there you go.
yeah, she's a metalhead. Sweet little Vietnamese woman, and she's a headbanger. Wow. So Brendan is co-creative studios.
Yeah.
Talented, super talented. And I'm with you, Eighth Sinner. I don't like a lot of music, and I could listen to that. I
No, that
love
was good.
about Nathan.
What happened?
I love the lyrics with Nathan. I wish I could pull it up because it was so, and the chorus, crazy good chorus. So
Yeah.
much talent in one place. So much talent. So all right, well, we have covered everything I think except for Ben. Though I have 4 minutes from my having to say goodbye. Any more questions, guys, in the chat, or from you, Ben or Nathan?
I just wanted to ask Ben if he had an update real quick that you want to get in.
Yes.
Nope. Okay.
So for the next lecture, I'm going to get that cone fired up, and that's my plan. So you guys get to see the cone Tesla coil, and I'm gonna run it upside down, right side up, and I think I'm gonna try bifilar. So I'm gonna just try it all and put a lot of current through it and see, and then move up on my electret work. I'm in communication with Brent, Mr. Lanius, and he's always teaching me more, so it's awesome. Also, too, Ian and I are looking into a patent of alternative propulsion, and I think a guy put it out in 2004, but it's a full patent, so it's been peer reviewed, but it's a fascinating way of alternative propulsion. Doesn't look like he's ever built the machine, but he wanted to get the patent out there, so anybody who builds it, they have to pay him $1. So, so I mean, Ian's still sorting through it, so it might be nothing, but it might be something super unique type of propulsion that we've never thought of before.
You know, I have a question for you, Sean.
Sure.
If I wanted to create ion wind out of a Tesla coil, can I just use AC to do that?
It's a good question. I mean, it's sort of polarity affected. So if you're changing polarity in AC, it'd be more of a back and forth. That's why you really don't feel any air when you see the plasma breakout on the Tesla coil, because it's going back and forth so fast. It's not really pushing air, versus the DC high voltage I'm working with. You can feel it pushing away.
Okay.
But I don't really know a lot about those gravity. The tin foil, and you put it with the straws, and it levitates, and you have to tie it down with string. You know what I'm talking about?
Oh, I know what you're talking about. Those little lifters. Yeah. It wasn't for that. I was looking at an ion thruster, but I wanted to connect it to a Tesla coil, so I wanted to see if it would make a high voltage hiss if I put the electrode and the ground a little bit apart. You know what I mean? can I get enough energy in there to get that?
Well, I wasn't experiencing that when I was connecting the Tesla to the ground. I wasn't sensing any change in the environment. No wind, no movement, no energy.
But that's with the round coil. What about the regular coils?
Same thing.
Same thing.
I run all the coils to ground. What did you think about changing the copper sphere for ground?
That was awesome. That
blew
was
me away.
well. It makes sense if you think about radio frequency and floating ground. If you create a secondary equal to the capacitance of the ground, then you have a floating ground.
Yeah, that's right. Portable. I honestly thought it was just gonna diminish the signal. I didn't realize it was gonna be huge.
Yeah.
So that's pretty awesome. And I didn't think about it being floating. So interesting. There's so
Okay,
many.
I'm back.
Hey Ben, we missed you. John Bingham says virtual ground.
Yes, virtual ground. So Ben, do you have any updates for us real quick?
Hi
Give
Mike.
me 1 second. I need to put my headphones on.
Mike, don't just joined.
Nice. Okay, going down the rabbit hole.
Good to see you guys. Our chats are so fun. There's
They are.
So many smart people. I feel like they're just the geniuses in the chats. These guys are amazing.
I agree.
Sorry about that.
Oh, hi Jabber. When did you join?
So Ben, did you have an update for us?
Yeah, I wanted to give you guys a preview. I know I showed you, Nathan. I want to give everybody a preview of the what Michelle Morel has been working on and what we plan on putting out to you guys soon, sometime this year at least. Which is the Project Lumen, and you've seen that. That's the Tesla lamp that we've been developing.
Okay.
And it's based off of Michelle's pancake coil design. I'm going to show you it briefly, but it's going to be a do-it-yourself kit that we're going to put out for people so they can build it themselves. And it's going to be very efficient. And Project Lumen is spelled Lumin, as in luminiferous. So let me pull that up. Give me 1 second. Is that it?
I run my iPad on the side because I can't see sometimes on the chat here. Plus, it's an extra viewer, and I liking the channel. Kind of cheating.
Right on. Well, I appreciate that.
So, hey, were you able to check, Nathan, if I was a member? Because I signed up.
Hold on. Give me 1 second. Is it under the Mad Coiler or was it under?
Should be Sean Calderon. Plus, your values are too low. You need to have higher values.
Yeah. Well, I don't have a lot of material on there at this point in time, Sean.
Oh, you're worth it, man. For all that you've done.
I have a face on here with no name.
A face?
Joined a day ago.
Oh, hey, Nathan, that conversation you had with Evo, do you have that? Is that recorded on video or was it just a phone call or something?
Oh, no. It was just an email real quick. It wasn't anything real big.
Okay. I forgot to ask you that. Sorry.
No, it's okay. Go ahead, Ben.
So No, it's okay. We don't have an exact time frame of when this is going to be out, but we're going to try to put this kit out for you guys, which is a desk lamp using Michel's Tesla Fusion interweaved pancake coil. And this is really cool because, in his words, this coil should be creating a ton of scalar waves. Scalar waves are produced when two electromagnetic waves of the same frequency are exactly out of phase, opposite of each other, and the amplitudes subtract and cancel or destroy each other. The result is not exactly an annihilation of magnetic fields, but a transformation of energy back into a scalar wave. This scalar field has reverted back to a vacuum state of potentiality. Scalar waves can be created by wrapping electrical wires around a figure 8 in the shape of a Mobius coil. When an electric current flows through the wire in opposite directions, the opposing electromagnetic fields from the two wires cancel each other out and create a scalar wave. And he says, maybe if he can create a receiver coil, we might be able to capture some of those scalar waves. Okay, and a couple of tidbits on this. He did not have to actually find the resonant frequency of this coil. It's in resonance from the minute you connect it. It's it's insane. It's in resonance from 0 ohms all the way to 10K ohms.
What?
Yeah. He says, I think it's because the wires are all exactly the same length, and we have a process that he developed for this frame that we're going to show you how to wind it and build your own kits here. But currently the projections are, I think he said he was able to power, I'll show you the pictures, but a desk lamp off a 9-volt battery for approximately 60 hours, I think was the projection. That could be, yeah, that's very good if that's correct. So we still have lots of testing to do, but here is the video. Oh, actually, I had more pictures to show you. I'm sorry. There it is. Okay, so let me get through the pictures first, and I'll show you the video. So there it is. That's going to be like the little kit that we're going to put together for you guys to sell on the Coil Kits Lab Shop.
That is awesome.
And,
yeah, it's really cool.
And it's not the final design, so keep that in mind. I still have to pick out a correct light bulb for it. I'm thinking about something old-fashioned like this, like the incandescent, like Tesla-like old-fashioned light bulbs.
There you go.
So, yeah. So, but again, you know, it'll all depend on the efficiency of the load and all that. So we have some testing to do, but it's going to be a fun kit. I have a quick video of it working, and that's pretty much all I have.
Nice.
Yeah, it's fun. I'm really excited about this one. Really excited. We're gonna go over it when Michelle sends the kit to me. We're gonna go over everything. As you can see, Michel has really been kicking butt lately with his designs. This is all him. So, you know, we have to give him credit for a lot of this. Oh, I did have one more picture of the circuit. So we have a proper circuit board that's going to be printed for this baby, and we have a picture of that. Oh, and one more video I wanted to show you of some packaging designs for the Lightning Thief. So just 2 more quick things.
Yeah, Jarvis says you should have Michelle back on.
Yeah.
Due to his like scheduling and stuff, it's hard to. But I've been trying to get him, and he is going to get with me soon. Hopefully, when we have another we get together every once in a while and hash out our research together. And cross-reference everything. So when we do that again, I'll discuss it with him and see if he has time soon to, you know, come back on and discuss some of his work. Because I'm really impressed by all the stuff that he, you know, has been coming out with and showing me. And this specifically, this is the circuit, the latest circuit that he's developed. Amazing stuff. Amazing stuff. And I can't be more grateful for all of his contributions to, you know, the work that we're trying to do and the Fringe Science team as a whole. You know what I mean? So it's really, really impressive stuff. We have to give him a massive shout out and massive amounts of credit for this. It's basically all him. And yeah, and I'm just trying to, you know, do right by him pretty much at this point. So, and then
that PCB, Ben, did you work with him to design that PCB?
No, that's all him.
Do you know what software he worked with?
I'm not sure. That's a good question. I could ask him when I talk to him next. Yeah,
I appreciate it. And maybe if you can ask him too, does he do commissions? If, let's say I said, hey, can I give you an amount of money to build a circuit board that I am thinking of? Because he looks like he's really good at it.
He is very good. He's very talented, and yeah, I'll run it by him. I'm sure if he has time, he probably wouldn't have a problem with it. He's very gracious like that and very charitable. I couldn't be more grateful for his contributions. Excuse me.
That's awesome.
Nice.
That's the one thing about the group that Nathan's brought together is a bunch of generous people.
Yeah. Yes, everybody has been, including Nathan himself. Everybody's been awesome. So, like, I couldn't be more grateful. I feel blessed. I do try not to take too many things for granted. You know what I mean? Because we do have a good thing going on here.
And it takes a lot of work for something to run smoothly like this. And that's Nathan. He covers all the bases. He checks all the boxes. He chases people down. He kindly throws them off the show. Seriously, it's people. When you have a lot of great people collaborating, it's usually because there's a great leader, and so I love it that we have a good leader.
Yeah, awesome. Nathan is an awesome leader, and he's helped me more than I can quantify. So, if you get the where I'm leading with that, it's just tremendous amounts of help. I wanted to show you guys this though, real quick. This is just some packaging that I've been coming up with for the Lightning Thief. I want you to let me know what you think.
That's pretty cool.
Yeah.
Yeah, I thought it wasn't bad for whipping it up real quick. It's got the features on the side and all that. It's not a final design, but if I decide to order some boxes, it'll probably look something like this.
It's a lot of work.
Yeah, it's not easy, but we're getting there. We're almost at the point where I think I need like $120 worth of equipment just to complete the final 5 for you guys. Like it'll probably make 5 or 6, but yeah. So once I get those that final those final components, I should be able to package those up for you guys. Really exciting.
Nice.
Can I pay in advance? That way it'll soften the expenses. So, I mean, I'd be glad. I know you want to give it for free. You're wonderful, but I would like to pay for it, and that way, because I want to really get behind you on what you're doing.
Yeah. No. So here's the thing. I actually I have, and this would help me out more. I have something called Throne, and it has like an Amazon shopping list of the components that I need to complete everything. And if somebody wants to like go on and donate, and I'd say instead of donating, just use Throne and buy one of those components for me, and that would help out a lot. There's I think a bunch of capacitors that I need to complete the circuit right now. That's I think $44. But there's a list of components on there. There's about $120 total that I need to complete everything.
Email me the link if that's okay.
Yeah, I can email you. And
awesome.
yeah, because to be honest, we're really close in trying to get these out. That's really the only thing I need to test is the capacitor with the open circuit, and then I should be able to, you know, like determine which circuit method is good for which thing. Because I right now I'm only testing the closed circuit. I've never actually tested the open circuit that Michel developed. So that's the one that's dangerous to use, though. Keep that in mind. I'm going to have a toggle switch on there for open versus closed. And when you have it on the open, I want you, like, I have a instruction manual already typed out for you guys.
Nice.
It has all these warnings in them, but I want to emphasize that when you do have the open circuit, Michel did say that he got a lot of ozone without a load attached. So you just want to keep that in mind.
Okay. Little ozone's not bad, but a lot of ozone's not good.
Right. But that was it with his coil. You know, the Lightning Thief, it should theoretically work with any bifilar coil, right?
Yeah.
But with some minor adjustments, depending on if yours is really, really small. But
I see.
Yeah, but it should work. Should work for what you guys are doing. I'm just really excited to get them to you guys. Honestly, it's really a cool device. I've been having a lot of fun testing with it.
This sounds good. Sounds really good.
Yeah, sounds great. Awesome. Right on, guys. All right. I know Sean's got to get going here, guys. It's been an awesome show. I'm going to feel those zaps for quite a while.
Yeah.
I have little burn marks or something under my beard. Just watch.
And I think it's called Schadenfreude, where it's called pleasure at other people's pain. So we had some Schadenfreude, didn't we? Horrible.
Oh,
well, it's good to laugh. You know, it's good not to take life too seriously. So I like that we do that on this show. You know, we don't take things too seriously. We like to have a laugh every once in a while.
yeah. And Ben, tell Michel anytime if he wants to do a morning show or whatever he wanted to do, we're all in.
Yeah, we can definitely work around his schedule and do something special for his case. I definitely would want to get him back on the show. He's got some invaluable insights just based on what he's been doing with me and the coils, and let alone all the other stuff that I probably don't even know about that he's doing, you know?
Yeah, you never know.
Yeah.
We all have scalar questions to ask him because he worked on it last time and built one. So I want to understand it a little better from someone who has the thing already built.
Same here. I'm in the same boat, Nathan. Like I want to learn more about scalar too, because that's like an area that I'm kind of fuzzy on. So yes, I think he'll be the perfect resource for that. It'll be a lot of fun to get him back on if he's up for it. But you know, yeah, I'll talk to him. Definitely. I'll run it by him. Right
on. Okay, guys, it's been a great night. Thank you, Sean, for presenting today. It was an awesome presentation. I appreciate that.
Thank you. Appreciate it. You guys are awesome.
Thank you, Ben.
Guys.
Yeah, of course. Thanks, Nathan. Thank you, Sean. Thank you, chat. You guys have been awesome. Joe, Mr. Lanius, all you guys.
Jabber. Mike don't.
Mike does, yes. Love you, Mike.
Coat, Stefan, the list is long. All right,
everybody's
guys.
Yeah.
Much love.
Okay. Have a great night. Have a great night, guys. Thank you.
Thanks.
Thanks everybody in the chat. Really appreciate you.